Hello everyone, and thank you for joining me. As you can see, I have elaborated on the topology in comparison to the previous video, and the reason why I did that is because I wanted to talk a little bit about EIGRP and the features that pertain to EIGRP. And the best way to understand the features of EIGRP is to role play a little bit and to put ourselves into a particular context or a scenario in which those features become handy and when to use them and when not to use them. So then you can kind of understand what we're trying to get to. So to do that, what I've done is we still have our core, okay, so that doesn't change. What I've done is just for visibility purposes, I put router 1, router 2, router 3, and router 4 because I have configured the loopback addresses. So a loopback address is basically a non-physical address that remains up at all times. And it's configured with 11111 on this particular router here, 2222 on this particular router here for edge 2. Core 1 is loopback address 3333, and this is loopback address 4444. So it just makes things a little bit easier when we're going through the configuration and you can actually see what's going on, okay? I would like to mention that I've also created an access layer. Well, this is a router on a stick, right? So we have a layer 3 VLAN that is basically bridging this layer 3 interface, which is bridging between two VLANs, okay? So if traffic from VLAN 44 wanted to reach any particular IP in VLAN 77, it would go up to this particular interface and then come back down. That's what a router on a stick is, where you have multiple subnets or sub interfaces that basically bridge layer 3 broadcast domains. Okay, so this is considered a core to distribution router because it has this interface that is, again, a layer 3 interface down towards the access layer, but it also pertains to the core as well. So it does have a certain responsibility in providing reachability information to other routing domain participants. So that's why it's a core to distribution. In this particular circumstance, we've divided the responsibility between the core and the distribution, but we have the exact same setup in a sense that we have VLAN 88 that bridges off this layer 3 VLAN over here, and we have another VLAN that essentially bridges off this interface VLAN as well. But again, we've just separated the responsibilities of distribution and core, whereas in this one we've collapsed them onto one router. Okay, so having that said, what I would like to do is just go through the configuration that we have up until this point. So as you can see, interface 00 and interface 01 are what primarily are configured on each and every single router. So for all intents and purposes, this is 00, which is matched up with 00. This is gigabit Ethernet 01, which is matched up with 01, and so forth and so forth, okay? So let's take a look at the configuration again. So as you can see, interface gigabit Ethernet 00 is part of subnet 0, which is occupied by it's a /30 subnet, so .1 on this particular interface, and on edge 2 it's .2, and this is where they create that point-to-point interconnection. All right. What I've also done is, if you take a look at the EIGRP configuration, I have allowed EIGRP updates to be announced on that particular subnet. That is what this network command does. This network command basically says that if there are any interfaces that are active on this subnet /30, because that's what the 3 stands for, is because it's the inverse mask of a /30, that EIGRP updates are allowed to be announced out that interface. And as you can see, it corresponds, and this was edge 2, but as you can see, it corresponds with edge 1. And the other interface, edge 1, with gigabit Ethernet 1, participates in subnet 4, which is this subnet over here, right? It matches with core 1, which is router 3, and you can see how they will announce EIGRP updates to each other as well to be able to create that neighborship and be able to teach and learn about routes that exist within the autonomous system. And this is how you actually begin building your routing domain, is you start creating this association between routers to be able to effectively then update routes and start building the routing table. So moving forward, I'd like to take a look at the configuration. So if we go on Acme Edge 1, for example, you can see that where we left off is we have these are all the routes that are learned via EIGRP. So these are all the point-to-point interfaces that are not locally connected to this Edge 1 router. And these are all the loopback addresses that do not belong to him. So this is, the EIGRP is updating that Acme Edge 2 is has or obtains or has connected the 2.2.2 interface. Acme Core 1 is announcing the 3.3.3 interface, loopback interface, and Acme Core 2 is the owner and announcing the loopback 0 4.4.4 interface. And you can see that this is how he actually begins populating his routing table. And the same thing goes for Acme Edge 2, right? And they start Acme Edge Core 1, or Acme Core 1, which is router 3. And you can see how, again, he sees 1, he sees 2, he does not see 3 because 3 is directly connected to him, and he's learning 4, and this one will not learn 4. He will learn about everyone else's but himself, right? So you can see 1, 2, and 3, but he won't learn 4 because 4 is a directly connected route. If I go like that, you'll better understand it. See, you'll see that right there, like that. So that's currently where we stand right now, and our objective now is to be able to get traffic from this particular workstation to go up, go out, and reach the internet. So we need to be able to have this router go out and reach the internet, and the internet needs to be able to come down and respond to the request of this PC. So we want to have bidirectional traffic flow. And what we also want to achieve is a situation where VLAN 88 can reach VLAN 33, and VLAN 88, if he wants to, can go and reach VLAN 77 or reach VLAN 44. So we want to get inter-domain routing, and we want to get internet routing working for this particular infrastructure. Okay, so let's begin configuring. Now, the objective is to get end-to-end reachability, right? Whether it be the internet to your internal LAN or internal LAN to internal LAN. So what we need to do is we need to be able to announce these prefixes, these /24s that make up our 4 different VLANs, into the core. So let's concentrate on this particular segment here for a second. So the router or the network node that would be responsible for announcing out the 188.16.77 and the 70.55.44, both /24 networks, would be router 4. Okay, the reason being is because he is the interface that is directly connected or bridging these two VLANs together at a layer 3 level. So to do that, what we're going to have to do is we're going to have to go onto the router for a second, and let's just go onto the router. We're going to go onto router 2. And as you can see, I'm going to go show run interface gigabit Ethernet 02/77, /77 and /44. Okay, and the reason why I did that is because I want to be able to see the subnets. All right, so these are the 2 networks that I need to be able to announce into the core. So to be able to do that, I'm going to go config T, router EIGRP 1528, and I'm going to go network 0/255. All right, because I gotta announce what the interface is actually configured for. All right, so I'm going to do that, and I'm also going to do it for 188.24 as well. So let's see if that worked. Okay, so let's just take a look at the configuration. Begin router EIGRP, and as you can see, I am announcing out these 2 prefixes here. So what did I say? This network command is basically saying that EIGRP packets, updates, queries, acknowledgements, hellos, these 5 packets that we learned are allowed to be announced out any interface that pertains to this particular block of subnets, as well as announcing it out to other routers in the routing domain. So if I go on to Edge 1, which is over here, and remember router 2 was router 2 is over here, which is 444. But if I go into edge 1 and I now do the same command again, look, I'm getting now the two VLANs, the two access VLANs that are located behind behind router 4. Okay. However, we do have a problem. All right. So even though this network command has accomplished the task of being able to announce out, okay, so he's announcing out to router 2, he's announcing out to router 3, which eventually reaches router 1, that he knows, or he is the owner of 70.5544, and he is the owner of 188.1677, that he has these routes or these prefixes connected to them, right? Even though this network command is doing that, the other downside is that EIGRP updates are also being announced on this link. All right, so we have a little bit of an issue here, because if I go back and I decide to do a wire capture on this particular link, you can see that EIGRP packets are being broadcasted out on this particular interface, which is not a good thing, right? So what's happening is that the router that has the responsibility of participating in the core also has a leg in the access layer, and is now trying to create a adjacency with another network element in the access layer. So essentially what that means is that if I bring my little hacker over here, okay, if I bring my hacker, let's log into him for a second. Okay, let's log into him first. So I have my hacker here for a second. If I decide that I want my hacker to connect directly to switch 3, let's see what happens. As you can see, EIGRP has just come up. So now I have just created an EIGRP relationship, right? With the interface on the core, which was purposely meant for access. Okay, so now we have a neighborship like this. And the downside to that is that this router now has complete visibility to our network, right? Because now he is going to get all the routing table of the core. And this is not a very good thing, all right? So to alleviate that, okay, to avoid this type of security issue, we would go on Acme Core 2. Okay, let's take a look at what we have here so far. All right. And as you can see, we have these two commands here, right? So we have to go router EIGRP 1528, and we're going to passive interface two 2.77 and 44. Okay, and what that does is it tears down the neighborship. So as you can see, the neighborship has now been torn down. So now this router here, sorry, my hacker, has now no way of knowing anything about the core. So we have just suppressed, we have just basically said, I want you to announce through the network command the EIGRP routes, right? Because I want these routes to be shown as internal because they are internal, okay? However, I do not want you to create neighbor relationships downstream to the access layer. And by doing that, we use the passive command to suppress those routes. So now this guy is basically gone. Delete. So he's no more. All right. So that is the first thing that we need to do. The second thing that we need to do is we understand now that these two particular subnets are being announced to edge 1. Right. So you can see that these two networks are being announced to edge 1, but on core 2, all right, he still doesn't know how to reach out to the internet. There is no method of him to reach any IP addresses out to the internet. He's only going to be able to learn about internal routes, if anything. he'll never be able to learn how to reach the 10.06.88.45. Now, for all intensive purposes and for simulation purposes, this is what's called a single homed environment. If you had a multi-homed environment to another ISP provider, okay, so another cloud provider, this is a multi-homed, and at that point, I would recommend that you use a external gateway protocol like EBGP, right, which is most common, the most commonly used protocol that you would use in a multi-homed environment. However, if your enterprise environment or your network that you're managing is a single homed environment, a default route would do absolutely fine, and there is no and that is not a bad thing to do. Okay, but if you're multi-homed, 100% you would want to run an EGP, exterior gateway protocol, and most likely you want to use EBGP. Okay, so for intensive purposes, because this is a single home, we're going to use a static route, and because Acme 1 was chosen as the router, the gateway router for our autonomous system. So all traffic that is not reachable within this autonomous system, pass it out to the internet, we're going to use a static route. So let's go back to Edge 1, and we're going to do show IP route. And as you can see, so we're going to go actually show IP interface brief, because I just want to see, yeah, so the interconnection with SHA is on .1, so I'm going to do config T, IP route 0 to 0, 0, 0, 0, 0, and I'm going to go .1, and name, I can call it internet if I wanted to, boom, like that. So that's a static route for the internet. So if I go show IP route, you can see that now oh, sorry, I don't mean to go so fast. So you can see that in my routing table, I now have a static route that's pointing towards SHA, okay? However, on core 2, I'm still not getting that route. All right, so that's a problem, because the only person that knows how to exit out of the 1528 autonomous system is Acme Edge 1. We need to now allow Acme Edge 1 to announce to his neighbors that he is the network node of last resort, that he is the exit point outside of the autonomous system. So all prefixes that are not known within are allowed to pass out. So to be able to do that, we need to redistribute. So under this here, let's take a look at include begin router EIGRP. So if I do config T, I go router EIGRP like this, and I do redistribute static. And there's other things that you can add to this as well. You can add metrics, modify the metrics for this command. I'm just going to do redistribute static as just as a beginner basic redistribution. And what I'm doing is I'm basically saying that the static route that's pointing out in this direction here, I want you to redistribute it. So I want you to redistribute the 0.0.0.0.0 network to all your neighbors. All right, that's what I'm basically saying. So by doing that, I'm going to now go and take a look at core 2, and if I redo this command again, and I'll put D for short form, I can now see the default route, right? I now see the default route out to towards the internet. So if everything is working properly, and I go on VLAN 77, and I try to ping 106.88.45.33, I now have reachability. So the way it's working is because router 4 is redistributing these routes into the core, and because this router is redistributing the default route into the core, traffic is able to actually get from this direction and back down. All right, so we have now end-to-end reachability. The next objective is to get traffic going in this direction. So we did internet traffic, and now we're going to do intra-domain traffic. All right, so let's begin configuring this segment right here. Okay, now for what it's worth, this particular portion of the configuration is going to be identical to this portion of the configuration. It's going to be identical. However, there is a little bit of a caveat when we look at the relationship between these two routers. And that's the reason why I broke up the responsibilities between each two routers, to be able to show you exactly what I'm talking about. So let's just go ahead really quickly and configure Acme stub router. Okay, so let's just take a look at the configuration that we have here, and it's just a very basic EIGRP configuration, and we do have the sub interfaces configured just like we had on the other side. So what we're going to do is we're going to go config T, and we're going to essentially announce, because the responsibility of announcing these prefixes on the shoulders of the Acme stub. So the Acme stub is responsible for announcing out those prefixes, and the core router, Acme Core 1, is then going to then begin populating that advertisement out to the rest of the core. Okay, so that is the little difference that we have here, but there is a little bit of a caveat, and we'll get to that in a second. So let's just go back and configure our stub area network, stub router for a second, network, and we're going to announce, and we're going to have the same problem that we had on the other side, where we're going to be announcing the EIGRP packets downstream to the access. So we're also going to perform the passive interface command on that. Okay, so I just launched these network commands, so I just want to make sure that I'm getting them on the advertisements to, and you can see that I am. So 33 and 88, these packets are arriving on Acme Core 1. I'm going to go to Edge 1. And you can also see that they're properly advertised to Acme Edge 1 as well. So that's really good news. So let's just continue with the passive interface, because we have to block or suppress better the EIGRP packets from going downstream. So that's 33 and 88. Let's take a look now at the configuration. And you can see that we are now announcing out towards the core. We're announcing out towards the core the prefixes, and we did notice also that they're being advertised by Acme Core 1 to their respective neighbors, which is a good thing. And we're also blocking the EIG packets downstream to the access layer. So we can say that this is complete. This section is completed. Now, to show you the little tweak that we need to do, because this relationship is essentially a stub, right? So this area is a stub. There's nothing behind here. We need to understand one thing. And to be able to understand this, we need to pay close attention to what I'm about to do. So over here, I have a user 2 in VLAN 44. So user 2 in VLAN 44 is this guy. All right, so I'm connected to this guy. And I'm going to purposely launch a continuous ping to this network node that's out on the internet. So I'm going to launch this continuous ping. All right. Now, while I'm launching this continuous ping, I'm also going to start a packet capture on this link. All right, because I want you to see what's actually going on here. So if we analyze the packet captures, we can see hello packets being sent. Actually, let me just filter EIGRP. Let me just filter on EIGRP. You can see that hello packets are being sent, right? You're not seeing acknowledgements because we've already passed that stage, and we're not seeing any queries because there hasn't been any reconvergence in the core of the network. See, query packets and update packets are used update packets in particular are used when you start the neighborship from the beginning, and query packets are sent when you are trying to find alternative paths to a destination that has been lost. All right. So under that premise, I just want to do one thing, and I'm going to go over here, and I'm going to go to Acme Core 1. So I'm going to IP interface brief, and interface 02 is what we need to pay attention to. All right, so interface gigabit Ethernet 02 is configured with the IP address of 17. I'm going to go ahead and shut that down, and I want to show you something. 02, and I'm going to go shut. I'm going to flap the link, right? I'm going to flap it, and we should see a reconvergence. So do you see how the neighborship came back up? So you see how there's hello packets, update packets, right, acknowledgement packets, etc., and they rebuilt the neighborship. But the one thing to pay close attention to is that there was never a query, right? Now, the query happens when there's a problem with the reconvergence, when there's a reconvergence in the core to find an alternate path to a destination. And we also have this ping going, right? That has nothing to do with the link in question in terms of neighborship, right? So what I'm going to do is I'm actually going to go on Acme Core 2, and I'm going to shut down this link. I want to force a reconvergence, and I want to see what happens here. Okay? So that's what we're going to do. I'm going to shut down the interface. So config T, interface, gigabit Ethernet 0, 1. Okay, because that's the one going up to edge 2. And I'm going to do a shut. All right, I'm going to go down here because I want to get the most updated packet, and we're going to hit boom. So look what happened. So this packet right here is what we have to pay attention to. This is a query packet. Okay, this is a query packet. So what happened is when I brought down this link, when I shut down the interface, Core 1 sent a packet, a query packet, okay, to every single router that it has a neighborship BGP on to find an alternate path for convergence purposes. The problem with this query packet going downstream is that it goes nowhere. He's basically asking the stub to find him an alternate path to somewhere else. But the stub doesn't have nowhere else to go besides back to router 3. Router 3 is his exit point. So that query packet essentially makes no sense. It's just it's a waste of a packet, right? So what we're going to do to mitigate that is go on router 1, and I just want to show you one more thing here. Oh, topology. Oh, sorry, my bad. Neighbor details, and you can see that this neighborship that he has with 18, which is the interface of Acme stub on gigabit 02, is considered is considered identical to the rest of the neighborships that are in the core. The problem is that router, it does not actually pertain to the core, and therefore that query makes no sense. So we're going to go on the Acme stub router, and we're going to go config T. We're going to go router EIGRP 1528. Oh, sorry. And we're going to go EIGRP stub, enter. We'll relook at, so by doing that, what's happened is that you've reinstantiated the neighborship, because now it's a different type of neighborship than it was before. And you can see this by doing the show IP EIGRP neighbor details under Acme Core 1. You can see now that it sees Acme the Acme stub router as a stub peer, and therefore it is going to be suppressing queries. Okay, so we still have this ping going on this side. We still have this ping going. On Acme Core 2, I'm going to go no shut. I'm going to bring the link back up, start a reconvergence again. Okay, and let's take a look and see what happens. And there you go. You're not seeing the query packets anymore. You're seeing update packets, right? Because it's updating the stub and letting him know about what is going on, but he's not querying the stub for alternate paths to a destination based on the disservice that I initiated in the core. So that is what the stub command does. Is it just basically tells the stub command here basically tells its neighbor, hey, I'm a stub. There's no point in querying me for alternate paths because there's nothing behind me. Okay? So we're at a really good point because right now our current situation is that router 4, which is Acme Core 2, is announcing out the 188 prefix for these two subnets, and the distribution router is announcing out to the core router these two subnets. Okay, and the default route is now being advertised by Acme Edge 1. So our routing domain has all the necessary information to correctly route traffic internally and externally. But what I would like to do is I want to just take a moment and talk about how EIGRP performs its path selection process. How does it actually begin populating its routing table? Well, to do that, I want to focus on two prefixes. I want to focus on prefix 188.16.77 and 188.16.88. These are the two prefixes we're going to be focusing on, okay? So to do that, we have to go onto Acme Stub, the Acme Stub router. So to go on the Acme Stub router is directly connected to those subnets. So once it begins creating neighborships with the core and etc., it still begins building its topology table. So the first things first, what it does is it starts building its neighborship table. So show EIGRP neighbors. And you can see that it has one neighborship with Acme Core 1. And then it begins building its topology table. And these are all done through the updates that they send to each other. So we said we were going to focus on 188.16.88, which is this particular prefix. And as you can see, this router is directly connected to those two subnets. Well, in particular to this one subnet. And as a result, when it applies the dual algorithm to this particular prefix, it has a feasible distance of 2816. The feasible distance on the Acme Stub router is then announced in an EIGRP update as a advertised distance or a remote distance to Acme Core 2 or Acme Core 1. So if I go to Acme Core 1 and I perform the same show IP EIGRP neighbor topology, and I look for 188.16.88, you can see that the advertised distance that was provided by Acme Stub is 1826, which was his feasible distance. And what happens is that Acme Core 1 then performs the dual algorithm, and from that dual algorithm, if the feasible distance of that prefix is higher than the advertised distance, we have what's considered have met a feasible condition. And that feasible condition means that now this route is eligible to be a successor. So let's take a look at 3072. So 3072 on Acme Core 1 is now advertised to Acme Edge 1, IP EIGRP topology. 3072. It's advertised as its advertised distance, and it's advertised as its remote distance. So 3072 is now Acme Edge 1's remote distance. He performs his dual algorithm, and his feasible distance, if it's more than the advertised distance, it's seen to have met a feasible condition, and therefore the route is a valid successor. So this path is a successor. And what happens is all the successors are then inserted into the routing table. And as you can see, that route is in the routing table. Perfect, right? Awesome. Now, the things change, I think, a little bit when we're talking about 188.16.17, because we can understand, even by visually noticing, that this path should be preferred over this path, right? We can see that. But what about if there is an equal path to the destination? Let's see what happens. So to do that, we're going to go on to Acme Core 2. We're going to show IP topology, EIGRP topology. And we're going to take a look at 77. So 188, 77 is directly connected, so therefore it has a feasible distance when it applies the dual algorithm of 2816. Let's see what happens when he announces it to core 1. We have it up here already. Oh, 77. So you can see 2816 is the advertised distance. He applies his dual algorithm. You get 3072, which is higher. The feasible condition is met. And this is a valid successor. And the same thing goes for edge 2. But let's take a look at edge 1. So for edge 1, you can see that the route that's being advertised is being considered via Acme Core 1. Now, why is that? Oh, no, sorry, 77. We're looking at 77. You see how there is 2 successors via Acme Edge 2 and via Acme Core 1. Perfect, right? But which one's going to the routing table? Both. Okay? And that's how EIGRP performs its path selection process. It receives the remote distance, calculates the dual algorithm, applies its own feasible distance. If the feasible distance is higher than the remote distance, the feasible condition is met, and therefore the path is valid. Therefore, we have a successor. Therefore, it's allowed and eligible to be populated into the routing table. Hopefully that was good. I hope you like this video series. If you like it, please click like, subscribe, and it'll let me know if you'd like me to do more. Okay, thank you.